In this video, I am going to explain 5 LEDs on and off simultaneously using TINKERCAD software. 5 LEDs on and off simultaneously. Using a TINKERCAD software, first of all, write the code and then simulate, and we will see the results. 5 LEDs on and off simultaneously. First one, procedure. Pick up 5 LEDs in different colors. Pick up 5 LEDs in different colors. From TINKERCAD. Source from TINKERCAD source. Second point here is pick up a breadboard. Pick up breadboard. And Arduino board. Arduino board from software, from the TINKERCAD source. TINKERCAD source. This is the second one. Third point is generally the LEDs has 2 legs, anode leg and cathode leg. These 5 LEDs cathode legs are connected to ground. Different color 5 LEDs, different 5 colors LEDs, anodes, not anodes, cathodes are connected to ground. Fourth point here is select 5 digital pins. 5 digital pins from Arduino. From Arduino board. These pins are pins selected from the Arduino board or Arduino board or 13, 12, 11, 10, 9 and 9. What fifth point here is all these LEDs anode pins are connected to these pins. All these LEDs anodes, not pins, anodes are connected to these Arduino pins. Suppose red LED anode. Red LED anode is connected to 13th pin, that means digital one of 13th pin of Arduino. This is the one color. Next one, green color. Green LED anode is connected to 12th pin of Arduino. Next one, next color is here 5 colors. First color and the second color. Third one is blue. Blue LED anode is connected to 11th digital pin of Arduino. Next, fourth one, yellow color. Yellow LED, colored LED anode is connected to 10th digital pin of Arduino. Fifth one, last one, orange. Orange LED anode is connected to 9th digital pin of Arduino. First of all, pick up 5 LEDs from TINKERCAD software and also pick up breadboard and Arduino boards. 5 LED has generally 2 legs, anode leg and cathode leg. All 5 LEDs cathode legs are connected to ground, and ground of that Arduino board is connected to these 5 LEDs cathodes. And the anodes of these 5 LEDs with different colors are connected to Arduino pins, 5 Arduino pins. We have to select 5 Arduino pins. 5 Arduino pins, 11 from 13th to 9. Once connections are completed, next write the code. Write the code. Write the code for 5 LEDs simultaneously on after 100 milliseconds simultaneously off. Write the code. First one, the code is generally 2 types of declaration part. 2 types of blocks are there: preparation block and execution block. In preparation block, define the pin configurations, and in execution block, assign these pins to what to do. Okay. First one is in void setup. Void setup. Curly brackets. Here we use 5 pins: 13, 12, 11, 10, 9, 1, 2, 3, 4, 5. By using a pin mode statement, configure these pins, whether it is output pin or input pin. Generally, these pins are output pins. Output pins. Whenever these pins are acts as output pins of the output pins, that means they acts as a source supply to these 5 LEDs. Okay, next here we use pin mode. One is pin mode. Configure these pins, 5 pins. Because we use 5 LEDs, pin mode, P small, I small, N small, M capital, O small, D small, E small. 13th pin as output pin. Semicolon. Here there is no gap here. Next one, pin mode. Twelfth pin output. Next, pin mode. Output. Next one, pin mode. 10th pin output. Pin mode. 9th pin. Once configure these pins, close with curly brackets. Generally, here 2 slashes means compiler does not execute. The pin mode is the pin number. Configure the pin number. Configure the pin number. Here pin mode 5 pins are selected from Arduino board. Here pin number is 30. Configure means whether it is output pin or output input pin. The 13th pin acts as output pin because whenever these pins are digital pins are acts as output pins, that means acts as a source supply to these anodes, these LEDs, not anodes, LEDs. Next, coming to execution block. This one is the preparation block. This one is preparation block. Next, coming to execution block. While loop. Here, our aim is 5 LEDs simultaneously on after 100 milliseconds, simultaneously off. We choose a for loop for integer I is equal to 1, I less than 6, semicolon, I plus plus. Each and every while loop functions start with some curly bracket. After for loop, you can start with some curly bracket. For I is equal to 1, integer compulsory. For I is equal to 1, I less than 6 means 5 times the loop is repeated. During that 5 times, you have to do something that means digital write. Set the next step is set these 5 pins. During this interval, these loop intervals, set these 5 pins. Digital write. 13th pin is high. Digital write. 12th pin is high. Digital write. 11th pin is high. And digital write. 10th pin high. Set these pins by using that digital write. Set these pins whether it is high or low. During this loop interval, you have to choose high. Digital write. 9th pin is high. 9th pin is high. Delay 100 milliseconds. That means 0.1 second. We go for simultaneously off state. All these are meant for simultaneously on state. Once for loop is executed, okay, completed. Next one. Again, for integer I is equal to 1, I less than 6. 5 times the loop is repeated. I plus plus. Curly bracket start. Digital write. Thirteenth pin is low. Digital write. 12th is low. Digital write. 11th pin is low. Digital write. 10th pin is low. Digital write. 9th pin is low. Okay. Delay here. Delay is 100. Need not mention 100 milliseconds like that. Otherwise, some error is indicated. Hundred milliseconds here also. 100 milliseconds. In between for this one, the loop is completed 5 times. And the final one is close the bracket. We use another curly bracket. This is the code for simultaneously 5 LEDs on. After 100 milliseconds, that means 0.1 seconds. Simultaneously off 5 LEDs. Simultaneously off, simultaneously on. After simultaneous, these 5 LEDs are simultaneously on. After 0.1 second or 100 milliseconds, simultaneously off. That is continuous. That this code is uploaded and start the simulation. See the result. Next step is how to simulate this code by using some TINKERCAD. I have to create some login. TINKERCAD.com. Login. This one, TINKERCAD. Under circuits, already I have registered. Under circuit, create a new circuit. Set here, consider all components. Already I have explained, pick up 5 LEDs. Five LEDs. And also these are the 5 LEDs. Pick up this one, put here, and the next to change the color of these 5 LEDs. Pick up these 5 LEDs, and the next step is breadboard. Pick up breadboard. Here breadboard. Select this breadboard and place it here, and also select one Arduino board. This one is the Arduino board. And also select 5 resistances, limit the flow of current. Resistance. Here we use 5 resistors. Delete excess one, this one deleted. Rotate this one. Here the resistance value is 220 ohms. Change this value into 220 ohms. 220. The main function of resistor is to limit the flow of current. Here anode, cathode, and anode. We need 5 resistances. Click on that one. Control C and Control V. Click on that and Control V. Click on that one. Control C and Control V. Control C and Control V. 5 resistances. Here we use colors, different colors. Red color, and the next one is green color. Green color. Next one is blue color. Next one is yellow. Next one is orange. Here, consider, I have already explained, 5 pins are selected from this Arduino board. These pins are digital pins from the 13 to 9. 1, 2, 3, 4, 5. 13, 12, 11, 9, 10, and 9. Now, these LEDs are placed here. 5 LEDs. Red LED, next one green. Green one. Next to blue. blue, yellow, and orange. Next step is all these cathodes are connected to ground. That means here from the Arduino board you have to select ground. This ground is connected to here, and these this is the all anodes are connected to pins. All anodes are connected to the Arduino pins through resistances. Resistance play an important role. This is the resistance. This one is the resistance connected to one. These 13th pin is connected to red LED anode. The 12th pin of Arduino board is connected to green LED of anode. 11th pin of this one Arduino board is connected to blue LED anode. 10th pin of Arduino board is connected to yellow LED anode, and the 9th pin of that Arduino board is connected to orange anode, orange LED anode. Okay. Next step is all LEDs cathodes are connected to ground. These are our LED cathodes are connected to ground. Okay. These are the connections completed. Next step is write the code. Here we use code blocks plus text. We go for text one. Continue. In this setup, for LED built-in is there. The pin mode. Only one LED code has been written here. No, just start the simulation. We will see what happened. Only red LED is on and off. But our aim is 5 LEDs simultaneously on after 1000 or 100 milliseconds or 0.1 seconds simultaneously off. Code. Write the code for this pin mode. The pin mode. First 13th pin. 13th pin has output pin. Copy this one. And the 5 times are pasted here. 1, 2, 3, 4 for 5 pins. Okay, next 12th pin, 11th pin, 10th one, and 9. Okay, preparation block is over. These pins are declared. Configure these pins. Next step is execution blocks. Here we use some for loop for is there a is equal to 1 I less than 6. 6 less than 6 means I is equal to some increment is there. Initially 1. Initial I value is equal to 1. I plus plus means 1 increment is there. 1 is changed to 2. After 1 increment, 2 is changed to 3. 3 is changed to 4. 4 is changed to 5. 5 is less than 6. 5 times the loop is created here. As 5 we are considered 5 LEDs. I plus plus. Here curly bracket is open. Digital write. We use this one. Here digital write, not built-in LED. Here use pins are selected. 13th pin is set as high value. Okay. Copy this one and I have to create 4 statements, similar statements here. 1, 2, 3, 4. Here 13. Next one is 12. Okay. And 9. Once this loop is 5 times repeated and close this one using this one. And one more statement I have missed here. Delay. Here delay is delay 100 milliseconds. In that bracket, 100 means 100 milliseconds. That means 0.1 second. Again, we have to create some loop. So many ways write the program. Here we use instead of 5, use low. Compulsory. This one is close with this one. Okay. This one integer I. Initially I value is 1. The 1 less than is 6. Go for incremented one. I plus plus. Okay. Next step is I is equal to 2. 2 less than 6 and go for I plus plus like that. Have to 5 times the loop is repeated. During that time, you We have to assign these statements here. Delay after delay 1 millisecond, 100 milliseconds, that means 0.1 second. Go for another one. This is the code, total code, and start simulation. This one is the code. 5 simultaneously 5 LEDs are on, and simultaneously 5 LEDs are off. If you want to change this code, instead of 100 or 200 or 2000, that means 2 seconds. Here also start simulation. 2 seconds. After 2 seconds only, the LEDs are off. After 1 second, the LEDs are on. After 1 second, the LEDs are on. Like that. By changing the delay value, delay means pause the program. Stop this one and go for code. Here 100 in that program. Our aim is 100. My statement is 100 milliseconds. Here 100. Okay. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Totally 19 functions are used here. Instead of 19 functions, have to use some statements, functions, reduce these number of functions. Here, suppose integer j. Integer j. Again, for loop is used here. For j is equal to 1, j less than 6, j plus plus. Pin mode j output. Instead of 1, 2, 3, 4, 5, we use 2 statements for declaration. Configure the pins. Here also, instead of writing this one, digital write j high. Here is digital j low. 5 times that one. Here based on that declaration and based on that program you have written. Okay, the code is executed. If any errors, display tell the display the errors. Okay, this is the complete task. The task is completed. Okay, thank you.